In this session, we are going to learn about Azure DevOps Server. Azure DevOps Server is an integrated CI/CD system that allows you to build and release software into different environments. It is integrated because it has a lot of features to manage your software engineering projects. But in this series, we are going to learn only about Azure DevOps pipelines and related components. Azure DevOps Server is yet another CI/CD system. There are other CI/CD systems available on the market, but they all have the same concepts as Azure DevOps Server. They all have the concept of build pipelines. They all have the concept of projects. They all have some notion of build agent. So regardless of the CI/CD system that you use, the concept that you are going to use here or learn here are applicable for any other CI/CD system. For example, if your company currently using TeamCity or Jenkins or Hudson, which are all famous CI/CD system, the concepts that you are going to learn here can be directly applicable for them as well. This learning series is all about how you can integrate Microsoft software or Microsoft technologies with AWS, and that's why we chose Azure DevOps Server as our CI/CD system. Let's first try to understand the concepts behind Azure DevOps servers and some of the terminologies and how it works. So you have this Azure DevOps server. So it could be in your on-premises, it could be on our lab environment, maybe it's the Azure hosted DevOps server. There is something called a collection. So inside a collection, you can have multiple projects. A project usually represents a given software, maybe your HR application, maybe your finance application, maybe some kind of a mobile application that you are building. So a project is a place where you organize your documents, your wiki pages, your project plans, your build artifacts, your build definitions. So think of it as a place where you manage your software engineering project. Let's go into Azure DevOps Server and then try to identify where these projects are. I'm in my Dev machine, and you can find that I'm on this Azure DevOps server, the root location. So if you type here, you will go into the root location. And you can find that I have already created 4 projects. My build test, my cat app, my donkey app, my tiger app. So these are all different applications that we are going to manage with the help of Azure DevOps Server. And all these projects have the same structure. So for example, if you go into my build test, you can find it has a summary, a dashboard where you can keep things like the build test results. You can have a wiki page that describes the project. You can have Kanban boards here where you can define some task for your developers, allocate them, and then build them. You have your Git repositories or SVN repositories here. You have the pipeline, which we will focus more on this learning series. You can also define test plans where the testers can go there and then test the software and then give the result or feedback of that test. And then there are artifacts where you publish the build artifacts. The structure of the project is similar for all the projects. So if you go into the root of Azure DevOps, if you select, for example, my cat application, you can find the same structure here, right? The pipelines, of course, may be different, but the structure of the projects is pretty much the same. So if you go into my tiger app, the same structure you will find. This learning series is not a deep dive session about Azure DevOps Server. Azure DevOps Server is yet another CI/CD system like Jenkins or TeamCity. So our focus is not around learning all the cool features of Azure DevOps features, like for example, Kanban boards, test plans. But we are going to focus more around repos and pipelines. The reason being, the objective of this course is to teach you how to integrate a CI/CD system with AWS services. So the place where all these cool things happens is around repos and pipelines. So we are not going to go into details around how to create wiki pages or dashboards or test plans or artifacts, but we will focus most of our course on pipelines and repos. A project can have multiple pipelines. So one pipeline may be used to build 64-bit deployment. Another pipeline may be used to build, let's say, 32-bit builds. Another pipeline may be used to build production software. Another one may be used to build pre-production software. Or you can have a pipeline that does weekly build, a pipeline that does nightly build, or pipeline that is executed every time a developer commits something. So it's a pipeline is nothing more than a set of steps that need to be executed to build, run, test a software. So you may only have build steps, or you may have build step plus test steps. You may have build steps, test steps plus deployment steps. So it's up to you to define that. A given pipeline can have multiple agent jobs. And I will come to these agent jobs shortly. So an agent job is nothing more than a construct to package and hand over a task for an agent to execute some steps. An agent job can have multiple steps. So these build steps can be build the software, upload the file to a file share location. It could be running some unit test cases. It could be simply running a PowerShell script to print something. Or it can be a Java application build step. It could be invocation of a web service. So agent job can execute a set of build steps. And these build steps, or the agent job, get scheduled in one of the agent pools. So you associate an agent job with an agent pool. And you can have multiple agent pools. The pipeline 1, the agent job 1 may be associated with agent pool N. Agent job N also can be associated with the same one. Agent job 2 also maybe can be associated with the same one. Or maybe you can associate agent job 2 with agent pool 1. It really doesn't matter. It's a shared pool of resources. Project 2 can also share agent jobs, agent pools for its build activities. Let's see how we can create a pipeline and then add a build agent, create few build tasks. So I'm in my root of Azure DevOps server. So let's go into the build test project. And under pipelines, if you go into the builds, you can find that I have already defined a build and it has executed several times. All the execution of a build appears in this section. And if you want to find an existing build definitions, you can go into this folder icon and you can find that the build definition that I have already created. Let's create a new build pipeline. To do that, either from here or here, doesn't really matter. If you create a new one, you can define new build pipeline. So let's create a new build pipeline. You need to first specify what's the source control that it is based out of. In this case, it's the build test project. And you want to based out of the master branch of this repository, right? Click continue. And then you can define a template to define the build steps. For example, if you are building an ASP.NET web application, there can be some common build steps like getting the content from the source control, building it using MS Build, running some test using MS Test or some kind of a unit testing framework. So there are a few steps that these ASP.NET share. So you can start it with the template And similarly, you have templates for Java application, template for .NET Core application. In this lesson, we are going to just create an empty job. So when we create that, it creates a pipeline. You can associate a pipeline with an agent pool. So I have defined like 2 agent pools here. Let's select AWS build pool. I can give this pipeline a name. I can tell it something like my pipeline. And then you can add agent jobs. So by default, it adds an agent job, one agent job. If you want to add more agent jobs, you can click here and then add an agent job. You can add as many agent jobs as you want. And these agent jobs can inherit the agent pool from the parent, like this. Alternatively, they can have their own specific agent pool. So example, AWS build pool. So in this lesson, we don't need any more, more than one agent job. So let's remove these agent jobs that are not needed. So let's remove it, confirm, I don't need this job. Let's remove this. Let's keep a one agent job. So how can I add build steps into this agent job? To do that, you can click this plus sign here. And you can define the task that you want to add. For example, you can see type CMD for command line. So let's say you want to execute a command line as part of this pipeline execution. Maybe you want to execute a PowerShell command. So if you type PowerShell, you can find that there are few PowerShell commands that you can execute. There are some AWS PowerShell commands. You can execute PowerShell on target, but in this case, we are going to execute a PowerShell, just a pure vanilla PowerShell script. Click add. And then you can configure these tasks. So for example, in the command line, I'm going to say, I'm going to type something echo, let's say, hello from command line. And for the PowerShell script, I can select a file from the source control system if I want. So in this case, it doesn't have any PowerShell script. So I'm going to write an inline PowerShell script. So this PowerShell script, let's say I'm going to say hello world, hello from PowerShell. Just to make it different, let's say hello PowerShell 911. So I can write these build steps, multiple build steps to make my software. I can also define more advanced execution patterns for these build steps. For example, if I select this PowerShell, if you go into the control options, you can say whether you want to execute these steps or not. So in sometimes when you are building this pipeline, you want to skip some build steps. You can just disable it by removing the check mark from this place. You can also say how this is going to execute. For example, you can say PowerShell task should execute only when all previous tasks have successfully executed. So for example, if you don't want to execute any of these tasks, if the previous one or the command line one fails, you can specify like this. If you want to execute this task, even if the previous task has failed, you can select this option. So in our case, I don't want to continue running the pipeline if a previous step fails. So I keep it only when all previous tasks have succeeded. So these are just simple build steps. There are other different build steps you can add. For example, .NET Core build task. You can add zip file in task. You can execute AWS task, like for example, these different tasks that you can find here. So these AWS tasks, you will not find it by default. They come from a marketplace plugin. So if you go out in your build system, if you don't find these AWS related tasks like upload to S3 bucket, do Elastic Beanstalk deployment, you can check out the marketplace. And in the marketplace, there are multiple plugins available for you to include in your build steps. For example, if you want to send a Slack message, you can do that with the Slack integration. And I have already installed these AWS tools for Microsoft TFS server. So if you type AWS, so this plugin is already installed in your lab environment. If it is not, you can click it, and then there will be a button to install it. Let's say you are not using Azure DevOps Server as your CI/CD system. Maybe you are using some kind of a third-party solution to do this execution. And in that case, you may not find plugins for AWS in the same way that you find in this plugin directory. So these are some of the plugins available, or the build tasks that you can use to interact with AWS services. But it's not a problem because all our APIs are exposed in command line and PowerShell. So in the same way that you interact with command line PowerShell, you can interact or invoke any of the AWS APIs, and you don't need these plugins. And in most cases, when you go into more advanced customization, you will not use any of these plugins. You will directly script them using PowerShell or command line. So that's how you add different build steps. So I added build steps. Remember to save the your pipeline. So click save. You can select a folder where to save it. So in this case, I'm going to save it in the root of the folder. Click save. So once I save it, if I go into builds, here you will not find it because here it shows only the executed pipelines. So if I go into my folder here, you can find that my pipeline is saved. Now, how can I execute this pipeline? To do that, you need to go to the queue and then select the agent pool that you want to target. So in this case, by default, it's going to be AWS build pool. I target it, and the branch I want to select is master branch. And to start execution, I can queue a new build. So when I queue a new build, it starts building process. If I go inside that, you can find that it's executing the build steps that I have defined there. So it's executing the checkout of the source control content, execute the command line. So if I go into the command line script, you can find that it has executed this message, echo hello from command line. And also if you go into the PowerShell job, you can find that hello from PowerShell 911. That's how you create build pipelines, build steps, and then execute it. The history of execution, you can find it under builds. You can find that my pipeline I executed once, so you have this one execution. But if you go into my build test sample one, I have executed it multiple times. And that's why you find these multiple executions here. If the build fails, it will mark as this red sign, or sometimes when you cancel it, it's marked as red sign. And if it is successful, you'll find that green indicator. So if I go into my pipeline that I just created, and when I queue it, it asks for the agent pool to execute. So where's this agent pool? So this is a shared agent pool that you can use in different projects. It's not only limited to build test. To find that, if you go into Azure DevOps, the root location, and if you go into the admin settings, because you have permissions to access this, you can go into agent pools, and here you can find the agent pools. By default, it comes with a default agent pool. I have created a one called AWS agent pool. If you want to add a new agent pool, you can create a one with new agent pool. Give it something like my test agent pool, my test pool, let's say. It's just a name that you give, and then you register agents under this my test agent pool. So for the moment, I don't need this. So let's delete this agent pool. Click OK. So you can find that AWS build pool is already been defined, and there's an agent already registered under this. And how to register this agent, we'll discuss in another section. But here you can find that agent is already registered. It's online. And to disable this agent, I can say disable this. So when I take that check mark off, it's disabled. So while it is disabled, if I go into my previous project, if I go into the build test, I go to the pipelines and then queue a new build. I select AWS build pool. Now this pool, although it has a registered agent, it's not enabled. So when I queue one, what will happen is that this will wait until an agent comes alive. As of now, it doesn't have an agent because I have disabled that agent. So if I go into my DevOps and go to this section, again agent pool, select this and then enable this, that build job that is half executing, if I go into the pipelines, now executing, you can find that it's executing its steps. It has successfully executed the steps. Let's say agent job 1 has some build steps that needs to have .NET Framework 4.5 installed. Let's say this is a build task that wants .NET Framework 4.5. And also imagine that there's a custom demand that it makes that whoever the agent that this build job going to get executed has to have the custom capability of department equals finance. What the build system will do is it will check the associated agent pool and then check whether there is an agent with that capability. For example, if agent YN says that it has .NET Framework 4.5 installed and a custom capability where the department equals finance. So if it finds an agent with the capabilities that the agent job demands, this agent job will get scheduled in this agent. For some reason, if you don't find an agent with all the capabilities that this agent job requires, this agent job will not get executed. Let's say the agent job 2 also demands the same capabilities and there's only one agent with the capabilities. So in that case, let's say this agent job 2 may be from project 2 or maybe project N. Then whoever comes first, in this case the job agent job 1, will first get executed on the only agent that has these capabilities, and the other job will get delayed until the first job is complete. And once that first job is completed, this agent will be free and the agent job 2 will get executed if it demands all these capabilities. Where this comes into picture is, for example, let's say you have a very important application, or let's say you have an agent that can deploy or has permissions to deploy into production. So you can say this agent job demands a production deployment capable agent, and unless that agent is available, it won't be deployed. You can also use it to target different tools. For example, let's say this build execution needs some special libraries or tooling to be installed on this agent. A classic example is, let's say you are going to execute some AWS PowerShell scripts that invokes AWS services, and you want to have AWS PowerShell tools installed in one of these agents. So in that case, you can define, hey, I want an agent with AWS PowerShell tools already installed. Maybe you are going to execute a special build process that needs to have special libraries installed. In that case, you can define these capabilities and target agents based on those capabilities. These agent pools also can be used to target, for example, frameworks or operating systems. For example, agent pool 1 may be building has Linux operating systems running these agents. Agent pool N may be running Windows operating system. So to build your Windows application, maybe you need to have an agent pool with Windows machines running behind the scene. These agents can be in the same machine with in different folders. Alternatively, they can be in different virtual machines. You can, for example, have one agent in AWS that deploys AWS related artifacts, another agent in, let's say, Azure that deploys Azure related artifacts, another agent maybe in your on-premise environment that deploys on-premise related artifact. Alternatively, you can have all these agents in, let's say, in one EC2 instance that does, for example, Azure deployment to on-premise deployment. So you are totally flexible in how we are going to arrange this agent pool. So let's now go and explore how we can define these demands and capabilities and target an execution of a job based on these capabilities and demands. I'm in my Azure DevOps server. So if I go into the root, you can find that I have a few projects. So let's select the build test project that we have been playing around with. And if I go into the pipelines, we already created my pipeline. Let's edit that. And in the agent job, you can add demands. So in this case, I'm going to add a demand. The demand is department equals finance. So this could be any key value pairs that you're going to add here. So I'm going to save this. And after saving that, I'm going to queue a new build. So if I queue a new build, let's say I select AWS build pool to queue this. So the build has been queued. So I can go to the build from here by clicking this number. Alternatively, I can go to the builds and then wait here. So this is the build that executed. For some reason, it failed. So let's see what happened. If I go into that, it gives an error saying no agent found in pool AWS build pool, which has satisfied the specified demand, department equals finance. So it didn't find an agent, so it failed. So let's see now how we can add that capability to that agent. So let's go into the root of Azure DevOps. If you go to the admin settings, select the agent pools. And if you go to AWS build pool, which we queue that build, and select the only available agent. And here you can find there's a tab called capabilities. So if you select the build pool and the agent that you are targeting, make sure that it's always enabled. And if you go to the capabilities, you can find that there are a few capabilities that got created as part of this agent registration. We will come to, in another section, how to register your own agent here. But for the moment, you can find that this agent, when it install and when it register against Azure DevOps Server, it already indicated some of the capabilities it has. Things like agent version, what's the MS build path, what's the operating system it's running, process architecture, and things like that. You can target based on these automatically configured properties. Alternatively, you can add properties manually also. So here I'm adding a capability. In this case, I'm going to say department equals finance. And I'm going to save that. So I have added a manual capability saying that this the department equals finance. So it could be something like agent type equals AWS, where you are keeping this agent in AWS side. Maybe you want to say certain libraries already installed, because when you install certain libraries, they may not appear here. Only standard things are appearing, or the agent reports as capabilities. So in that case, you can define them. So in my case, I have defined a simple capability called department equals finance. So after I added that, if I go, make sure that you save it. If you go into Azure DevOps, go to build test your project, go to pipeline like before. So previously we knew that this failed because this capability was not there. So we can go to the builds and then execute this my pipeline again. So let's queue one. AWS build pool is the targeted pool. Let's queue it. And in this case, it's going to be successful because it found an agent with the capability that I wanted, where the department equals finance. So that everything executed successfully. And that's how you target agents based on demands of the build steps. When my build got executed in the previous section, it got executed in an agent. So let's go into this build test. And then if I go into the builds, this is the build that got executed. If I go into the logs, you can find that, for example, if you go to the checkout, it has checkouted the content to a special folder in that machine where the agent ran. But how do I know which folder it got executed? For example, as part of this pipeline, so if you go into the build, this pipeline that I created, maybe you want to know copy a file from one folder to another. Let's say you executed this PowerShell and you downloaded some file into the working folder of that agent. But how do you know where to download that? Or how do you know where to copy that file? How do you know the, if you go into this build ID as 95? For example, when this build completes, you may need to rename the file as something like, let's say you create a zip file and you want to name that file with this build ID. So you know, hey, this is the build, and you can relate this build with the artifacts that it created. The way to do that is through build variables. So if you go into Google and then search something like Azure DevOps Server predefined variables, or Azure DevOps Server previously known as TFS. So if you search TFS predefined variables, you can find that there are some variables that you can use. Here you have something called agent home directory that you can get the working folder. You can find the build directory where agent is getting the build artifact and start working. So you can find that different build variables available. You can combine these build variables and then create your own outputs. So for the moment, let's try to find the location where the content get downloaded. So the one for that is build repository local path, the location path of the agent where your source code files are downloaded. So when you check out from the Git repository, this is where it's going to download the content. So let's copy this path, this variable, and let's try to output it into our PowerShell window. So if I go into my pipeline, this is the pipeline I created, edit it. And in the PowerShell window, so let's write something like write output, write host. And I want to know this variable. So it's $/ bracket. This is what I want to output. I can append it with different names if I want. For example, I could say something like plus hello. So I can mix some parameters. Even I can add another variable. So for example, the repository path plus the build ID. So let's for the moment take another variable. In that case, let's say something like build ID. So let's copy this. So let's add that also. So you can combine as many paths that you want. But the variables, when you are referring to that, you need to refer to them as $. Under the brackets, you need to put the ID. So let's save it. And then queue the build. In the AWS build pool, queue it. So 96 has been created. So let's go into the 96 and then see what is the PowerShell output. So PowerShell has been executed. So you can find that it has it got the working folder as built agent VSTS agent work. So this is where that it got built. This is hello is the one that I put, and 96 is the build ID. So you can mix and match these parameters. So this is where it got the source control. So if you referring to file paths, you can use these variables so that you don't need to hard code those values inside your build steps, because this agent may come and go, and places where the agent install may be different, and using variables you can easily get the file locations. You can also define your own variables. So for example, if you go into your builds, so this is the build that I created. If you don't have any execution, you can go from this file location, my pipeline, the one that we created, click edit. You can also define your own variables here. You can add your own variables. So let's say my variable, and the value is, let's say I love AWS. So that's the value of the variable. So let's save this, and maybe this is a connection string, maybe this is some parameter that you want to keep. So once you have this variable, let's say my variable, you can refer to them in the same way that you refer to predefined variables. You go to my whatever your pipeline, edit it, and let's say in the PowerShell you are going to have this variable. So same like before, you put the $, brackets, and you type my variable. So let's save and queue. You can do the same at the same time. Build pool. So 97 has been created. So let's go into that. So now it's executing this task. So it's successful. If you go into the PowerShell script, you can find that I love AWS is visible here now. So that's how you define variables, and they become really useful when you are doing advanced scripting.